వింటే సర్కిల్స్ వినొచ్చు కదా. అదే ఇంటికి వెళ్ళి వింటారా? వినండి, ఇంపార్టెంట్ క్వశ్చన్స్ చెప్తా. అయితే ఒకవేళ తర్వాత మళ్ళీ రికార్డు చూడండి ఏమా. మహాగణాధిపతయే నమః. Good evening. Hello. Am I audible, children? Yeah. Good evening. Now, I think am I audible? Just I want to explain you the problems, important problems from NCERT as well as some problems from R.S. Agarwal in circles. The first problem that I am going to explain you today is two tangents TP TQ are drawn to a circle with center O from external point T. Prove that angle PTO is equal to 2 angle OPQ. Okay. P, Q, T. Okay. Yeah. Yes. We need to prove this angle is equal to, what is required to prove? Angle PTQ is equal to 2 angle OPQ, sorry. Where TP and TQ are two tangents and PQ is the chord joining the point of contacts. Okay. We need to prove angle PTQ is equal to 2 angle OPQ. For this we need to do some construction. What is that? Join OQ. Join OQ. Now required to prove. Can anyone say what is angle PTQ plus POQ? What is angle PTQ plus POQ? Anyone? Angle PTQ plus angle POQ. Yes, 180 degrees. What is the reason? What is the reason, children? What is the reason? Angle PTQ plus angle POQ is 180. What is the reason behind it? quadrilateral. Opposite angles of quadrilateral. So the reasons what you said is wrong, children. The reasons are wrong. No. Yes. Krishna Pingakhya Patro. Who said this? Who is this? Because the other two angles makes 180. Yes. See, we all know that TPOQ is a quadrilateral. In this quadrilateral, angle TPO is 90 and angle TQO is 90. Angle TPO is 90 and TQO is also 90. So since sum of these two angles is 180, according to angle sum property of quadrilateral, sum of these two angles is also 180. Okay na? Cyclic quadrilateral ane reason ichindi, that is wrong. Cyclic quadrilateral reason wrong. Okay na? The reason is, since angle TPO equal to angle TQO is equal to 90 degrees. Angle TPO plus angle TQO is equal to 90. That's why sum of the remaining two angles is 180. Right. Next, consider triangle POQ. Consider triangle POQ. Now children, you tell me, what is angle POQ plus angle OPQ plus angle OQP? How much it will be and what is the reason? How much it will be and what is the reason? Yes, 180. 180, and the reason is angle sum property of triangle. Right. Now, let it be equation 1 and equation 2. If you observe both the equations, things which are equal to the same thing according to Euclid axiom, things which are equal to the same thing are equal to one another. So, what I can conclude? Angle PTQ plus angle POQ equal to angle POQ plus angle OPQ plus angle OQP. From 1 and 2. From the first equation and second equation, things which are equal to the same thing are equal to one another. We can conclude this one. Now, again, if you observe this equation, equals are removed from equals. Equals are removed from equals. The remainings are equal. Angle PTQ is equal to angle OPQ plus angle OQP. Okay na? But these two angles are equal. Angle OPQ and OQP both are equal. What would be the reason? What would be the reason, children? Anyone? Yes. POQ is an isosceles triangle. POQ is an isosceles triangle. So, this angle and this angle both are equal. So PTQ is equal to, we can write this one as 2 angle OPQ, or we can write 2 angle OQP also, no problem. We can write PTQ is equal to 2 angle OPQ or 2 angle OQP. Okay, na? Next question. Yeah. Again. PQ is a chord. PQ is a chord of a circle with center O, and point T lies outside the circle. TP and TQ are two tangents. Okay. And the radius is 5 centimeters, and the length of the chord is given 8 centimeters. Length of the chord is given 8 centimeters. And what we have to find out? This is given. Required to prove is length of the tangent. Required to prove is length of the tangent. Okay, children? Very, very important question. Now, the line segment joining the center to the external point and the chord joining the point of contacts. This PO and PQ both are having a relation. Can anyone say that? What is the relation between the line segment joining the point T to O as well as the chord joining the point of contacts? Yes, very good, singer. It is the perpendicular bisector of PQ. TO is the perpendicular bisector of PQ. That means this angle is 90 and these two parts are equal. PM is equal to QM. Not only that, angle between the common chord PQ and TO is 90 degrees. Okay, na? Now, PQ is given 8 centimeters. Then according to the statement that TO is perpendicular bisector of PQ, PM will be 4 centimeters. This is 4 centimeters. Now, can anyone say what is the measure of MO? What is the measure of MO? And the reason? The measure of MO or OM and the reason. So everyone says 3 centimeters. And what is the reason, children? Pythagoras theorem. Very good. Pythagoras theorem. Good. So this is 3 centimeters. Now consider triangle TPO, and triangle PMO. Observe these two triangles, children. TPO and PMO. What can you say about those two triangles? triangle TPO and PMO. What can you say about those two triangles? Yes, they are similar by AA similarity. They are similar by AA similarity. So ratio TP by PM is equal to PO by MO is equal to TO by PO. Since they are similar, we need to take the ratio. Okay. Now, whatever the values we have, insert in that ratios. TP, we don't know. PM, 4. PO, 5. MO, 3. I think no need to go further. We want TP and we are getting it. We want TP, na? I think we are getting it. How much it will be? 20 by 3. One of these two problems will be there in any one set, or in even basic paper. It will be there. Understood, children? ఈ రెండు క్వశ్చన్స్ లో ఏదో ఒకటి it will be there in the question paper on Monday, either in all sets or at least in one set. Okay. Next question. Prove that the perpendicular at the point of contact to a tangent to a circle passes through the center. This problem I told you we need to use method of contradiction. What he says? There is a circle and there is a line. There is a circle with center O and there is line L which is tangent at P. Line L is tangent at P. Okay, na? Now, what he says, if we draw a perpendicular at P, it will pass us through the center. That is what he says. The perpendicular that is drawn at P surely passes through the center. That's what he says. Or that is what we have to prove. Required to prove. What is required to prove? Perpendicular at P must passes through center. The perpendicular that is drawn at the point of contact must passes through center. That is what we have to prove. Okay? And we'll consider no. I told you now we have to solve this problem by using method of contradiction. So whatever he is asking to prove, we'll go in a different way. No. The perpendicular that is drawn at the point P will not pass us through the center. We'll take that one. Okay, na? This is center and this is Q. QP is perpendicular to L at P but not passing through center. not passing through center O. Okay, na? Right. Let us assume QP is the perpendicular to L at P, not passing through the center O. Now, construction, join OP. Join OP. What is OP, children? What is OP? Anyone? What is OP? Radius. I think everyone know the relation between radius and tangent at their point of contact. What is the relation between radius and tangent at their point of contact? I am considering one more point on line L. Let it be R. Okay. Now, proof. What is angle QPR? What is angle QPR? Angle QPR. Anyone? 90 degrees. It is 90 degrees. I think you know the reason. It is given. QP is perpendicular at P. That is drawn from P. It is given. QP is perpendicular to L at P. So angle QPR is 90 degrees. Now, can anyone say what is angle OPR? Angle OPR and the reason. What is angle OPR and the reason? 90 degrees. Good. And the reason is radius is perpendicular to the tangent at their point of contact. Radius is perpendicular to the tangent at their point of contact. So this is also 90. Okay, na? Now, from these two equations, what is our conclusion, children? QPR, angle QPR 90, angle OPR 90. What is our conclusion from those two? Yeah. Angle QPR is equal to angle OPR. But at one point, we are observing two perpendiculars. Two different perpendiculars. Will it happens like that? Or otherwise you can see, if we consider QP and OP are two different line segments, okay na? Then from the figure we can say that angle OPR is greater than angle OQR. If these two are different line segments, angle OPR is greater than angle QPR from the figure. But what we got? They are equal. That means these two are not two different lines, they are same lines. That means OP, QP must coincide each other. They must coincide each other. Otherwise, this will not happen. They must coincide each other, OP and QP. That means the perpendicular that is drawn at the point of contact must pass us through center of the circle. The perpendicular that is drawn at the point of contact of it must passes through center of the circle. Okay, na? Yeah. Now there is a quadrilateral. There is a quadrilateral. ABCD circumscribes a circle, and all the four sides of the quadrilateral are tangents to the circle. They are tangents to the circle. AB is tangent at P, BC is tangent at Q, CD is tangent at R, DA is tangent at S. Okay, na? Now, if a quadrilateral circumscribes a circle, what happens? What is the property that we can get? Anyone? Rhombus form అవుతుందా వంకాయల వెంటనే కంగారు. When a quadrilateral circumscribes a circle, then what is the result? Yes, very good, very good. Sum of opposite angles are opposite sides are equal. Sum of opposite sides are equal. Okay, na? Now, if ABCD is parallelogram, if ABCD is a parallelogram and it circumscribes a circle, then what we can call it as? In the first case, ABCD is a quadrilateral. Then sum of opposite sides are equal. It is neither a parallelogram nor a rectangle. But here, in the second case, given ABCD is parallelogram and it circumscribes a circle, then it becomes rhombus. Why? We know that sum of opposite sides are equal, and we know in parallelogram opposite sides are equal, na? So I can write this one as 2AB and 2AD. 2 get cancelled. AB is equal to AD. AB is equal to AD. So parallelogram with adjacent sides equal is rhombus. Parallelogram with adjacent sides equal is rhombus. Now children, please tell me what happens if a rectangle circumscribes a circle. What happens if a rectangle circumscribes a circle? Then we can call it as a square. Same procedure. We can call it as a square. Okay, na? Next. Next. I think everyone knows this problem, na? Everyone knows this problem. Is that right, children? You know how to do it? Very, very important border problem. We we need to join OC, and these two are parallel tangents, and required to prove is angle AOB 90. Angle AOB 90. Required to prove. So, can I take these two angles are equal? If yes, what is the reason? Angle POA and angle COA, are they equal? If yes, what is the reason? Angle POA and angle COA, those two angles are equal because triangle POA and triangle COA are congruent by RHS congruency. RHS అనొచ్చు, triple S అనొచ్చు. It may be triple S congruency or RHS congruency. OP equal to OC, AP equal to AC, OA common side. You can take it as triple S congruency. So triangle POA and COA are congruent either by triple S or RHS. In the same way, angle BOQ and BOC, angle BOQ and angle BOC are congruent. Okay, same reason, triple S congruency. Given that POQ is diameter, given that POQ is the diameter, now what will be angle POQ, children? What will be angle POQ? Angle POQ is 180 degrees, straight angle. Now, POQ I can write as 2A plus 2B is 180. A plus B, 2 of A plus B is 180. A plus B 90. A plus B 90. Then what is A plus B, children? What is A plus B? Small a small b. AOC na. Ritwik. Small a plus small b equal to AOC. Yeah. AOB. So that is done. Yeah. Now, there is another important problem. There is a quadrilateral circumscribing a circle. Okay. And we need to prove that the angle made by the opposite sides, the angles made by the opposite sides with the center of the circle are supplementary angles. We need to prove angle AOB plus angle COD is 180 degrees. The opposite sides of a quadrilateral circumscribing a circle subtends supplementary angles with the center. This is the problem, important problem. Okay na? construction over here. What is that? Join OP, OQ, OR, OS. Join OP, OQ, OR, OS. Where PQR are point of contacts. P is the point of contact of AB. Q is the point of contact of tangent BC, and so on. Now, proof. Children, can I take these two angles are equal? If yes, what is the reason? Okay. Yeah. Now, what are the other angles that are equal there? I think these two angles also equal. Is that right? Since these two triangles are congruent, these two angles are equal. And even these two angles equal. And even these two angles also equal. Is that right? Just you need to prove only one pair of triangles are congruent. CPCT angle SOA and POA are equal. Similarly, these two triangles are congruent, these two are congruent, and these two are also congruent. Okay, then? Now, A 2A plus 2B plus 2x plus 2y is equal to 360 degrees. 2A plus 2B plus 2x plus 2y is equal to 360 degrees, complete angle. Now, take 2 common. A plus B plus x plus y is equal to 360. A plus B plus x plus y is equal to 180. Is equal to 180. What is A plus B? Angle AOB. Plus what is x plus y? It is COD. Is 180 degrees. So, if a quadrilateral circumscribes a circle, then its opposite sides makes supplementary angles with the center. Okay, na? ఎక్సర్సైజ్ లో 12th క్వశ్చన్ కూడా చేసుకుని వెళ్ళండి. 12th క్వశ్చన్ అదే ట్రయాంగిల్ ఏరియా. టూ టైప్స్లో చేయాలి కదా, ఒకటేమో హెరోన్స్ ఫార్ములా అండ్ 12th క్వశ్చన్, అది కూడా చేసుకుని వెళ్ళండి, అది కూడా ఛాన్స్ ఆఫ్ హ్యావింగ్ ఇన్ ద పేపర్. ఓకేనా? నెక్స్ట్, if we see now, have you seen today's exam tip, children? Today's exam tip, anyone, have you seen it? Today's exam tip. Yeah. Yeah. What can you say about PR and QR, children? What can you say about PR and QR? They are equal. Why? PR and QR are equal. Why? RP and RT. RP and RT are the tangents drawn from an external point R. So they are equal. RP is equal to RT. In the same way, RQ is equal to RT. RP is equal to RT and RT is equal to RQ. Reason, tangents drawn from an external point of circle. Here external point is R. So from 1 and 2 we can say that RP is equal to RQ. Maybe a 2-mark problem. Yeah. Yes. Prove that the tangents drawn at the midpoint of an arc of a circle parallel to the chord joining the endpoints of the arc. A beautiful question which was asked in a board exam long before. There is a circle with center O. AB is an arc. AB is an arc. And P is the midpoint of arc. P is the midpoint of arc AB. And line L is a tangent at P. And AB is the chord. AB is the chord. And what we have to prove? What we have to prove? AB parallel to L. AB parallel to L. Or you take one more point, P, Q, R. AB parallel to QR. We have to prove that. Okay. What is AB, children? AB is an arc of a circle. AB is an arc of a circle. Okay. And what is the P? What is the P over here? P is the midpoint of arc AB. P is the midpoint of arc AB. Moksha, vintunnava jagrataga. P is the midpoint of arc AB. Okay? Right. That means what is given? Arc AB is equal to arc PB. Arc arc AP is equal to arc PB. That is what we mean, that P is the midpoint of arc AB. And we need to prove that the chord joining the endpoints of the arc is parallel to the tangent L. Right. Now construction, very very important question now. Construction. Join AP, join BP. Join AP, PB. Children, what can you say about AP and PB? Chords AP and PB. What can you say about those two chords? Chords AP and PB. They are equal. They are equal because arcs are equal, na? Equal arcs makes equal chords. Gurtunda 9th standard lo. Equal arcs makes equal chords. And equal chords makes equal angles at the center. Adi kuda undro gurtupettuko. Right. Join OP. That is also. Join OP also. Now, what is OP? What is OP, children? Radius. I think radius is perpendicular to the tangent at their point of contact. Is that right? Angle OPR is 90 degrees. Angle OPR is equal to 90 degrees. Radius is perpendicular to the tangent at their point of contact. ఇప్పుడు మనం AB parallel to QR, that is what we have to prove. And we know that angle OPR is 90. Now what is enough to prove, children, now? What is enough to prove? Keep required to prove in the mind. What is enough to prove? We know angle OPR is 90. And we have to prove that AB parallel to QR. Now for that, what is enough to prove? Angle BAP, and angle QPA. Indukra, Ritvik Singhal, why that much? Simple, na? If we prove this angle, or OP perpendicular to AB, over, Sham is right. If we prove OP is also perpendicular to AB, then corresponding angles are equal, then the lines are parallel. Over So now our aim is to prove OP is perpendicular to AB. How? Any idea? Radius is perpendicular to the cutter. You prove you have to prove Moksha. You have to prove that OP is perpendicular to AB. You cannot take it. Yeah. Children, join OA and OB also. Join OA, OB. Okay. Now see. Triangle AOP congruent to BOP. Is that right? Triangle AOP and BOP are congruent. Why? OA is equal to OB, AP is equal to PB, and OP is common side. OP is common side. Okay, na? So, by CPCT, this angle and this angle are equal. Is that right? Triple S congruence. Now, consider triangle AOM and BOM. Consider triangle AOM and BOM. Again, OA is equal to OB, OM common side, and these two angles are equal. SAS congruency. CPCT, these two angles are equal. Triangle AOM congruent to BOM by SAS congruency. CPCT, angle OMA and angle OMB are equal, but they form linear pair. They form linear pair of angles. Is that right? So each angle is 90. Triangle AOM is congruent to triangle BOM by SAS congruency. So therefore angle AMO is equal to angle BMO by CPCT, but angle AMO plus angle BMO is 180. It is 180. That means angle AMO is equal to angle BMO is 90 degrees. That means this angle 90. If a pair of corresponding angles are equal, the lines are parallel. If a pair of corresponding angles are equal, the lines are parallel. Is that right, children? Yeah. Next. So there is a right triangle which circumscribes a circle. Then how to find out its radius? This is of A units, B units, C units. Then how to find out the radius? You know it? Yeah. Join these two. Okay. This This is 90, this is 90, this is 90, and this is also 90. Then what is this quadrilateral? It's a square. So R. All the sides are radius only. If this is R, this will be A minus R. If this is R, this will be B minus R. This is A minus R and this is B minus R. Okay na? Now A minus R plus B minus R is equal to C na? A minus R plus B minus R is equal to C. Then A plus B minus 2R is equal to C. A plus B minus C is equal to 2R. Then radius is equal to A plus B minus C by 2. Try to keep this result in the mind, children. You may get objective type question on this. Okay na? Okay. In the given figure, isosceles triangle ABC is an isosceles triangle, circumscribes a circle. ABC is an isosceles triangle, circumscribes a circle, and BC is a tangent at P, AC is a tangent at Q, AB is tangent at R. We need to prove that P bisects BC. We need to prove that P bisects. What is given? AB is equal to AC. And what is required to prove? P bisects BC. That is BP is equal to PC. Okay na? Now how to prove this? Consider this one, children. AB is equal to AC. So AB we can write it as AR plus RB, and AC we can write it as AQ plus QC. This AR, AQ get cancelled. Is that right? AR and AQ get cancelled because they are equal. Tangents drawn from the external point of circle are equal. Now what is remaining? RB is equal to QC, but RB is equal to BP and QC is equal to CP. So here we can replace RB with BP and QC with CP. So BP is equal to PC. That means P bisects the side BC. Okay na? So these are some important problems. Don't forget to see the exam tips, children. There are some 33 exam tips are there. All the tips are very much useful to you. Okay. Tomorrow we'll go ahead with the similarity of triangles. Okay, na? So this is some important problems in circles. Tomorrow, similarity of triangles we'll see. And don't forget about exam tips, children. Just have a look on that, okay? Okay, Nana. Bye. Mahaganadhipataye. Dhanyavad. Thank you.